Good day, everybody. How are you all doing? Hope you're doing great today. It's sunny outside today here. I hope you are having a great day so far. And today we will continue our discussion on statistics. What is it all about? Yesterday we briefly discussed about statistics, that it is the science of, or it is the process of gathering data or information through surveys, then analyzing the information and making, coming to some conclusion based on the pattern from our analysis. So today we will continue further with data analysis and statistics. So I will try to explain in easy terms what is a data analysis process, what are the different types of data that we get in statistics. You may have always questioned what are the types of data, what are the types of information that we will be analyzing, and how do we come across such information. Okay, so stick here till the end. It will be an interesting presentation, I promise, and I will keep it short. Okay, brief and sweet. So here I go. Statistics and data analysis process. so so data analysis process consists of different steps. 1, 2, 3, 4, and 5 and 6 are basically the steps in collecting information, analyzing information, and making some conclusion out of this data analysis, the information that we have gathered. You ask me, how do I collect information? Well, you conduct a survey. Suppose you want to find out what is the mean age of the population of students at your college. Can you reach the entire population? It may be very large in number. So what do? You work with a simple random sample, a sample that represents the population. Suppose there are 50 students in the sample. You ask each of the 50 students, what is your age? Add the 50 numbers, divide by 50, get a sample mean age. And then we can make an educated guess about the population mean age based on the sample that we have obtained. Okay. So population, the entire collection of individuals or objects about which information is desired, is called the population of interest. In my example, population is the entire collection of students at your college. Can I reach the population at any one time? No, it's very difficult because population is large in size. Being large, we have to take time to reach everybody in the population. Therefore, we prefer to select a sample, a part of the population, which represents the population, and gather some information from the sample. Descriptive statistics, as the name implies, we characterize the sample data we describe by description of the data, patterns in the data. So descriptive statistics deals with includes collection, organization, and summarization of data. Basically, we describe the characteristics of the data. Where is most of the data falling? What is the center of the data? Then what is the spread around the center? So that's descriptive statistics. What is inferential statistics is another branch of statistics. Remember, I worked with a sample of 50 students. I got the sample mean age of all those 50 students. From that, I make an educated guess about the population mean age. This is inferential statistics, or drawing conclusion. Inference means drawing conclusion about the population based on the sample data. Okay. So here we define population is the entire collection of individuals. Sample is part of the population. Descriptive statistics describes the characteristics of the data that we have collected. Inferential statistics draw an inference from where the word inferential comes. Draw an inference about the population characteristic based on the sample data. So here they're looking at some information. They're looking at number of chews. Okay. Participants were, so this is a statistical study, you might say. Participants aged 18 to 45, initial observations. Each of these participants aged between 18 and 45, they had 5 pieces of pizza rolls to establish how many chews they do before swallowing the food. Before swallowing the food, how many times you chew the food. Okay, so that was the first session. Second session, they were provided with a platter of pizza rolls, and they were asked that they were told that you can eat as many pizza rolls as you like, and then you can ask for additional pizza rolls. So each person was also told how many times to chew the pizza roll before swallowing. Okay, group one given the chews equal to their baseline. So if they, on the average, if group one people chewed 20 times before swallowing the food, group one, they also chewed 20 times before swallowing the food. Group 2, 150%. That means 20 multiplied by 1.5 or 30 times they chewed the pizza rolls before swallowing it. And group 3, 200%. That means 2 multiplied by the base is 20. Base time is that chewing 20. 2 times 20 is 40 times they chewed the pizza rolls before swallowing it. Interpret the results. If you increase from 20 baseline to 30 chews, which is by 50%, they will eat less, 10% less food. And if you go from 20 chews in doubling the chews is group 3, second bullet. That means you went from baseline of 20 to 20 times 2, 40 chews before swallowing the food. They consumed 15% less. So if you chew 30 times instead of 20 times, you will chew 10% less. I mean, you will swallow 10% less, consume 10% less food. And if you chew 40 times instead of 20 times, which is your baseline, you will swallow 15%. So, what is the conclusion? You conclude that as you increase the number of chews, you consume less. Okay. Now we are going to talk about types of data and some simple graphical displays. So you have heard the word data again and again. What does the word data mean? Data is the plural of the word datum, means information. So types of information and simple graphical displays of information. Univariate, one variable. Data should involve only one variable, such as if I have collected a simple random sample of 50 students, I ask each of the 50 students, what was your age at your last birth? Age is one variable. It's a univariate data. Bivariate, I might ask for age and their height. Okay. By two variables, age and height. Multivariate might be age, height, and weight. Now there are two types of data in all of this, univariate, bivariate. So again, univariate is your age, bivariate, age and weight, multivariate, age, weight, and height. Now, all these we are talking about is numerical numbers, but there can be categorical data. For example, I might ask, find out from my sample of students what is the color of their hair. Okay, so that is category. It can be black, it can be brown, etc. So those are categories of hair. There is no numbers, whereas numerical data has numbers associated. So variable is a characteristic, data, pieces of information, categorical data, no numbers, categories such as color of hair. And so here is an example. UCLA's Higher Education Research Institute annually surveys 20,000 college seniors, asking if they would choose their current college again. Responses include definitely yes, DY, probably yes, PY, and probably no, PN, and definitely no, there's DN. So there are 4 categories of these are categories, no numbers. Definitely yes, probably no, and definitely no. So we sampled 20 students, okay? And these are the 20 data points that we get, okay? With a partner, to be prepared. What is an example of a bivariate data set that includes one categorical variable and one numerical variable? Okay, one categorical variable, like I said, what is the color of your hair and what was your age at your last birthday. Age is a numerical variable, color of hair is a categorical variable, categories of hair, no numbers. Okay, here we are doing bivariate data. Both of them are numerical variables. Height versus weight. Okay, height is in inches, weight is in pounds. These are numerical data because they are in numbers. They are numbers. Multivariate, if you also have pulse rate, multivariable. What are the multivariables? Height, weight, and pulse rate. Okay. Discrete numerical variable are dots on a number line, like on the left, 0, then 1, 2, 3, 4. An example of this is how many brothers and sisters you have. You can have 0 brother and sister, 1 brother and sister, 2 brother, 3 brother. So from 0, you discretely jump to 1, then 1 to 2, 2 to 3. Also, you're counting the number of brothers and sisters you have, as opposed to continuous numerical variable, which is in this case it is a continuous line between 18 and 30. On the right you see a line continuously drawn from 18 to 30. This can be miles per gallon, or how many gallons of fuel left in your car, how many gallons of gasoline left in your car, anywhere from 18 to 30 gallons. That is, you measure, and it can be have decimal values. It can be 18.5, it can be 22.1. Unless and until we measure, we don't know. And if we measure, it can have decimal values. That is any value possible. In this case, in the figure on the bottom right, continuous line from 18 to 30, including all decimal values. So that's a continuous numerical variable, something that is measured. Whereas discrete numerical variable is something that is counted on the left, 0, 1, 2, discretely jumping in terms of 1, no decimal values. Okay. So here the defined discrete numerical variable, something that can be counted or listed, and there is no decimal value possible, is discrete numerical variable. Continuous is something that is measured, such as how many gallons of gasoline left in my car is between 18 to 20, and it can have decimal value and we have to measure it. It can be any value in the continuous interval between 18 and 20 in the previous slide. So decimal values are possible. Point to note, discrete numerical variable listed, continuous numerical variable measured. The number of text messages sent on a particular day is recorded for each of the 12 students. Notice there is no decimal value. It is counted. So it is a discrete numerical data. So we can do frequency distribution for categorical data. Again, to remind you, categorical data means categories of data, such as types of credit card. Visa is a category, MasterCard is a category, American Express is a category, Discover is another category. Frequency. So you go to a grocery store, observe the customers who check out of the grocery store in 1 hour. How many of them are using frequency? How many of them are using MasterCard? How many of them are using Visa? How many of them is using American Express? Also, how many of them are used Discover? You add them up, all the counts in each category, that becomes your total customer size, and then you calculate the proportions of frequency or percentage in each category. So that's relative frequency, which is frequency of each class divided by total number of observations in the data set. For example, if there are 50 customers in 1 hour in the coming out of the grocery store, and 30 of them use Visa, then the relative frequency of Visa is 30 who use Visa, divided by 50. Total number of customers in 1 hour, 30 divided by 50 is 0.6. That means 60% of the customers are using Visa. Okay. So we can do a relative frequency distribution, which is a listing of all the categories and the corresponding relative frequency or percentage or proportion. Here they're looking at use of helmet. N means no helmet, NH means non-compliant helmet, and CH means compliant helmet. So here they looked at uh, observations. Okay, there are 818 plus all this. Okay, so they found out how many of them were compliant. That would be CH. N will be no helmet at all, which is not good. NH is non-compliant helmet. And they found out that out of 828, 586 are using compliant helmet. So the relative frequency of compliant helmet, that is a category, is 586 divided by 828, which is 0.708. That means almost 71% of the motorcycle riders, motorbike riders, they're using compliant helmet, which is a good sign. Interpret the results from the frequency distribution. You can see about 13% were not wearing helmet. How did you get N? Count the number of N is 104 divided by the total 828. It's 0.126 or 12.6% are not wearing a helmet at all. It's approximately 13%. So this table is called a frequency distribution because it has the different categories. In column 1, what are the categories? No helmet, non-compliant helmet, and compliant helmet. Category in column 1, the vertical line, column 1. And the corresponding frequency or count in the second column. Okay. A bar chart is a graph of frequency distribution for categorical data. Each category in the frequency distribution is represented by a bar or rectangle. Area of each bar is proportional to the corresponding frequency or relative frequency. The bar chart provides a visual representation of the information in frequency distribution. So first we draw a horizontal axis, write the different categories on the horizontal axis. The vertical axis is relative frequency, usual, and you place a rectangular bar above each category level. The height of each bar is the relative frequency. So different bars will have different heights. For example, if we do a bar chart of the helmet data, the height of the compliant helmet will be the highest. This is because it is relative frequency is approximately 0.71. Here they actually plotted, instead of relative frequency, on the vertical axis they plotted the actual frequency, and again the height of compliant helmet is the highest. Okay, so the area of each bar is proportional to the frequency. Non-compliant helmet is the next highest, and the least highest is a no helmet. Remember that was about 13%. Okay. From the bar chart, we see that the compliant helmet use category occurred. So most people, most bike riders were using a helmet which is compliant in nature. And the list one was no helmet at all, which is a good sign actually. Okay. We can do some display on dot plot. Each number is, or each observation is represented by a dot. So we draw a horizontal line, which is a number line. Then we put a dot on each top of each number, how many times they occur in the actual data set. So here is a dot plot. Okay. Graduation rate for basketball players. Okay. So we are dot plot of graduation rates. What percentage of basketball players are graduating? Okay. From this dot plot, you can see that there are so many dots on top of 100. Okay. That means majority of the schools are graduating 100% of their basketball player. But on the low end, there is 29%, which is not good. Okay. But most of them are concentrated by the second oval from the towards the right is between 70 and 96. Okay. Yeah, 70. You might say 98. Well, that's a good sign because most of them are graduating between 70 to 98% of the basketball players. Whereas there are some schools which are graduating, which has the highest number of dots. Each dot represents a school. So number of times the dot appears means that many number of schools are graduating 100% of their basketball players. Okay. So we talked about that. Okay. So that's the end of it. So we talked about dot plot. We talked about bar charts. We talked about frequency distribution, which is a table. We also talked about categorical data, which is this case no helmet, non-compliant helmet, and compliant helmet. Three categories, no numbers. We also talked about numerical data, which is number of text messages. Okay. And it is discrete. It is not continuous. How do you do discrete? Is something that you do list. Continuous is something that you measure. So let's see. I stop here today, but before I stop, let me get out of here. Okay. Wait a minute. Okay. Okay. So here I'm back again. So do you have any question? Do you understand what I said? I talked about different types of data. I talked briefly about how to make a frequency distribution. Then we talked about bar chart. Then we talked about dot plot. We also talked about categorical data and numerical data. Okay. So we talked about types of statistics, descriptive statistics, and inferential statistics. We talked about population, whole collection of all individuals, such as all students in the campus. And we also talked about a sample. We tend to work with samples because samples are smaller in sizes, easier to reach, easier to collect information from. Once we collect information from the sample, we can generalize it to the population, or we can make an educated guess about the population characteristic, such as the population mean age. That is inferential statistics. Okay. So I stop here today. If you like my video, please give me a thumbs up. I really appreciate that. If you like this video, share with your friends. And you and your friends, please subscribe to my channel by hitting the red subscribe button. Also, please drop me a comment. Do you like it? Do you want more of this kind of presentation? Where are you watching from? Why do you watch my video? Please write whatever you want to. Any question you have about the material, I will answer you. I guarantee I will answer you. And then please subscribe to my channel by hitting the red subscribe button. And also please do not forget to click on the notify button, which will notify you every time I upload a new video, which I do often. Okay. And I stop here today. Thanks. Really thanks. Really appreciate that. Again, please subscribe to my channel and please drop me a note. Please give me a thumbs up if you like my video. I'll be back tomorrow with another interesting video, interesting situation. Thanks for taking the time to watch my presentation. Take care. Have a nice day.